The constant a is such that the definite integral of ln x over square root of x from 1 to a is 6. And we are to show that a is e to the 1 over square root of a plus 2. So we need to show that a is e to the 1 over square root of a plus 2. Yeah, the notations are the same. If that is the case, we need to integrate the definite integral. So we need to evaluate the left side of the definite integral and set it to 6 to find the value of a. Okay, now we are to integrate ln x over square root of x with respect to x. Because we have ln x and square root of x, we would need to use integration by parts. And for integration by parts, we let u equals ln x. Then du dx equals 1 over x, or du here is 1 over x dx. If this is u, the rest must be dv. So dv is 1 over square root of x dx. 1 over square root of x is x to the negative 1 over 2. Then when we integrate, we add 1 to the exponent. That will be 1 over 2. So this is 2x to the 1 over 2. And when we integrate this using integration by parts, you have u dv, this becomes uv minus the integral of v du. So u is ln x and v is 2 square root of x. This is also 2 square root of x. They are the same. Then in that case, you have uv that will give us 2 square root of x ln x from 1 to a minus the integral of v du. So we have 2 square root of x, du is 1 over x dx. We can evaluate this straight out. This is 2 square root of a ln a. When x is 1, we have 2 square root of 1 ln 1. This part is going to end up at 0. Now for this case here, we are to integrate 2. That will give us 2 square root of x over x is x to the negative 1/2. So that will give us 2 square root of a ln a minus. So when we integrate this, we have 4 square root of x from 1 to a. Yeah, it's just like what we have over here. Then this is 2 square root of a ln a minus, this is 4 square root of a minus 4 square root of 1 is 4, which will give us 2 square root of a ln a minus 4 square root of a plus 4. And since from part A, we know that the definite integral of ln x over square root of x is 6, then 2 square root of a ln a minus 4 square root of a plus 4 is 6. That will give us 2 square root of a ln a minus 4 square root of x. Move the 4 over, we have 6 minus 4, which is 2, and we can divide throughout by 2. That will give us square root of a ln a minus 2 square root of a equals 2. Factor out square root of a, we have ln a minus 2 equals 2, and then divide throughout by square root of a. Ln a minus 2 equals 2. Sorry. When we divide So what we have over here is, when we divide by 2, this is a 1 here. So what we have now is this is a 1, this is 1, this is 1 square root of a. Then move the negative 2 over. We have ln a equals 1 over square root of a plus 2. And converting to exponential form, a here is e to the 1 over square root of a plus 2. So that is for part A. And part B, you need to verify by calculation that A lies between 9 and 11. Okay, to check that A lies between 9 and 11, what I'm going to do is I'm going to rearrange this so that when I rearrange this, I can move the A over. When I move A over, I have e to the 1 over square root of a plus 2 minus a equals 0. So what I do now is I let f of a to be e to the 1 over square root of a plus 2 minus a. I need to show that the 0 is in between 9 and 11. So to show that the 0 is in between 9 and 11, I find f of 9 first. So when I replace a with 9, I have e to the 1 over square root of 9 plus 2 minus 9. That gives 1.31. This is greater than 0. And I find the value of f at 11. So this will give me e to the square root, e to the 1 over square root of 11 plus 2 minus 11. And I get a value of negative 1.01. This is less than 0. Now, since this is less than 0, then we can safely say that 0 is f of 11 is less than 0, and 0 is less than f of 9, meaning that a must be in between 9 and 11. That is for part B. Part C, use an iterative formula based on the equation in part A, which is actually this equation here. To determine A correct to 2 decimal places, and the result of each iteration is to 4 decimal places. So in order to do that, we can rewrite this equation in part A here. We write this as a sub n plus 1. This equals e to the 1 over square root of a sub n plus 2. We are going to start with the iteration a naught equals 9. So if a naught equals 9, then a sub 1 here is e to the 1 over square root of a naught, which is 9, plus 2. And we have a value of 10.3123. So our iteration is correct to 4 decimal places. And that is a sub 1, 10.3122 decimal, if that is the answer. Then a sub 2 is e to the 1 over square root of a sub 1 plus 2. You just jab all these into your calculator. And that is 10.0886. Yeah, we have to continue that. A sub 3, we get, you just continue the same process. You have 10.1233. And a sub 4 is 10.1178. These two round to 10.12 to 2 decimals. That means they are converging to 10.12. Find a sub 5, and we get 10.1187. Therefore, we say that a is 10.12. These three are the same to 2 decimal places. Therefore, A is 10.12 to 2 decimals.